I was happy to have assisted to all the different presentations on battery recycling from Thomas, or your sugar slag integration into cement, which is really a big topic. So what I want to do now is try to tell another story, this time about marine and river plastics, which is a big problem in many countries. I want to show you perspectives, and what I try to do is to give you case studies to make understand why we should improve. Everything that you see I can send to you later on as a PDF. Just give me your email address and I send you the PDF. So with Pierre Kamsalum last year, he's from Cameroon. He's the co-author with me of this German handbook called Mechanical Recycling of River and Marine Plastics, and the reasons why we do too little. So I want to give you perspectives, I want to give you case studies, so it is a little bit a general overview that I want to give you. And for each of this kind of recycling, the upcycling, the closed loop recycling, the open loop recycling, and downcycling, I want to give two examples. Let's start with some impressions from Cameroon. To understand that we really need, in any locality, in any country, a good solution. What is evident in this photo is that the collection system is missing. So people in the neighborhood just throw into the street what they have. The bad thing is the animals will try to find food in between the waste, and you can imagine this causes illnesses of the animals, and also the farmers that they need the surface will have problems. This is the beginning of the problems. Here you see a pit, a canal, so all that plastic waste goes into it, and it goes on. This is a photo from a riverside, and you see there's some plastic bottles floating in the river. The problem is, and we come to this, is contamination. So here you see a photo of plastic bottles contaminated by seawood. And last but not least, a photo from a beach in Cameroon where you see plastic bottles that should be there. YICAPED is an association for the collection and the reuse of plastic waste. So here you see members of YICAPED doing the work of collection in a riverbed. And quite honestly, it's a job that nobody wants to do. It's hard, it's on-site, you take risks, and quite honestly, if we have plastics in the rivers or on the beach, we have done something wrong. But let's speak about the different possibilities where we can go to from this statement that we should do something out of river and marine plastics. Starting with upcycling. Upcycling means few applications for a little number of products, but we lose a lot of materials. If you speak about upcycling, it could be a beautiful product in the end. I will show you some of them. But what we don't see is the losses of material that you don't use. The market price of such an upcycled product is much higher than the initial product. And the LCA says production costs may be higher than in the initial process for the initial product. I give you two examples: art objects out of flip-flops and sunglasses out of fishnets. For closed loop recycling, I identify what I mean by it. I want to define it. It means it becomes exactly the same product that it has been before. Example, bottle to bottle. This is a standard in the, according to the state of the art. It's really everybody can do, but it needs some preparation and it needs quite pure products in the beginning, not to produce a lot of losses. But the good news is you have less losses than in the upcycling case. You have a similar market price. At the moment it's lower than the virgin product, but it's a similar market price. And the recycling, the mechanical recycling should cost much less than the production of the virgin product in the first place. So I give you two examples: PET granules out of PET bottles and PE granules out of PE films. Open loop recycling means that you do anything out of a pure product, so it's open, the choice that you have. So it will be another market price because it's not the same product. Okay, for example, we do a brick out of river plastics. This is an example that I quote. And you can also do, for example, PE bags out of PE flakes that come perhaps from other products. So the typical example is black PE bags, where you have all colors inside because it's black. You cover a little bit what is inside by the color, and it's the easiest way to make something out of PE films. Last but not least, downcycling. As other speakers would have said, this is not even downcycling. We also go to thermal reuse, recover, you call it. This is also a solution, and let's be honest, who are we to criticize solutions that work? Therefore, I quote co-product in the cement industry and plastic roads. First example, art objects out of flip-flops. So here you see, we are in Kenya, and here we have a beach cleanup, and you see all the different materials that they collected, and in nice bags. They have flip-flops in their hands, so they have taken away the flip-flops of which they make the artworks afterwards. But the big problem is all the rest. Okay? So what do? They wash them, they dry them, they form them into their art objects. I give you an example in the end. They have to glue it. Here you see already a photo. If you see between the rose and the deep blue and the light blue, that they have already glued the different layers one to another. And afterwards they adapt it to give a new form, and it becomes something like that. They sell animals, and in my home I have some animals out of flip-flops. So Ocean Soul says, we turn pollution into flip-flop artwork. For every 60 seconds that go by, we upcycle a flip-flop. This is their task, this is their job. Second example, the man in the middle of this photo is the founder of the ocean cleanup. And they do, as an example, they do sunglasses out of fish nets or gear nets. So, once again, we collected, this time not on the beach, but this time in the sea. They have big boats, big ships to make the collection. Then they sort it, they grind it, they wash the grinded material, They dry it afterwards, and they extrude to have granules, or pellets, as others would call them. And here we are. We have, in the end, you can do a new product out of these granules, and you do, in this case, sunglasses out of them. The Ocean Cleanup says we develop and scale technologies to rid the oceans of plastic. This is their mission. So these two examples show you that you can create a new product with a certain value, a much bigger value than it was in the beginning. Now I want to show you two examples very quickly of products that become products, the same products afterwards after the recycling process. For example, rPET, recycled PET granules out of PET bottles. So we make a recycled bottle out of other bottles in the start. And these are the kind of granules I'm speaking about, okay? It's not the same because they're not green, as you've seen in the photo before, but this gives you a hint. They're really small, and you can do new bottles out of it. Same thing for the films. Here you have a bale of films, and you see the organic contamination and some other plastics inside. And this is the end, when they have taken out all the colored stuff, the organics have been washed out. And these are examples of the state of the art. And I want to show you the process of the state of the art. And afterwards, I show you the parameters. First of all, we have a shredder that makes all the bottles, all the big films into small pieces. We have a pre-washing. It's, for example, a screw that is just mixing up the plastic pieces with the water. Then you have a grinder. Afterwards, it's in the same photo, the machine behind. Then you have, in some cases, we come to this later on, it is useful to use a hot wash, meaning not only a cold wash, but also a hot wash. And then you have a cold wash station. I would call it a rinsing station. And then you come to drying. And this is the normal washing process. Afterwards, what I do not say is you come to the extruder and you make granules out of it again. This is standard. So what are the parameters that we use? We want to remove the impurities. And we have process parameters. Let's speak about the process itself. A dry process means you don't wash the material. So it's a dry shredder, a dry grinder, and it works. And we'll see the case where it works later on. If you want to pass through the plastic waste through a wash line, perhaps just one wash step could be sufficient. There could be two, there could be three. What I showed you was that there were 3 wash steps: pre-wash, hot wash, cold wash. Inside the wash process, you can choose parameters. Water temperature. In the hot wash process, you can go higher up to have better results. It's like your washing machine at home. If you have very dirty from soccer, from football, whatever, you need more. You need really the hot temperature. Same thing with the detergents, the lye that you can put into such a hot wash process. The more dirty, the dirtier it is, the more you would need detergents. And last but not least, that you know also from your program of your washing machine, is the dirtier it is, the longer it takes. So you will, it will take more time to make this reaction time, to have this wash time, in fact. Okay. So you have already understood the first points: dry process, 1, 2, 3, wash step. They concern the process, so they are capex, their investment costs. And the second part, they concern the operation, water temperature, chemical agents, and reaction time. So you work basically on the operation costs, right? This is important to have in mind, that we have the two levels to work on. So we don't want to go into details, but we have different kind of impurities. Things that we add, for example, a plastic bottle has a cap and a label. These are added things. Then we have adhesive material such as sand. It's just, you can wash it very quickly out, because sand just lies on a film or in a bottle. You can wash it out very easily. Things that are glued, they are cohesive. They want to stick to the bottle. Takes some time to wash them out. And in the end, intrusive materials that you can only see in the microscope, that they inside the polymer structure, you have already impurities that are inside, and it's difficult to wash them out, evidently. So I want to show you a very simple thing, and it's really just to give you a hint how we work today in the industry of recycling plastic waste. Let's use a dry process for all the stuff that you put in Germany, would say, in the yellow bin for the selective collection, because they're just added materials, a label, a ring, a cap, and you just shred it, you grind it, and it falls off, it's removed, very easy, it works. Boom, 100% impurities taken out, because it's simple, they're just added materials. Same thing is for materials such as the rest of the lemonade inside of the bottle. You just wash it out. It's easy. It is not something that is sticking on the plastics. It's easy to do. It will take some time. You have to wash it. Therefore, I say you need at least one wash step. But then comes the point, what is cohesive between adhesive and cohesive? I don't want to define it today, but cohesive is more difficult, as you can imagine. So I say it is not possible to get rid of all impurities. I don't want to give numbers, but it takes you a lot of time, and it would take you perhaps chemicals and more time and a high temperature to do so. And we come to the intrusive materials, and yeah, you can take some out that perhaps want to go out, but intrusion, as says the definition, is difficult to remove, and it will probably still be inside the polymer structure of such a plastic after the wash process. So now I want to show you just the intensity of the resources that we use. For example, for the dry process, we need some energy. This is the red arrow. For the wash step, we need more energy, and we need some water. This is just to give you the indication. For 2 wash steps, you would need even more, and I don't want to get into the machinery that you will need, but it's evident that you need more water treatment. In Europe, it is mandatory to recycle. You cannot give it back to nature. Any water that you use in such a wash station, you have to treat it. So I'm showing here the water treatment effort, and it grows when you have more washing steps. So if you have 3 washing steps, you have to do more efforts to wash out the impurities which is in the water. Same thing, if you rise water temperature, you need even more energy, in this case thermal temperature, thermal energy, but it's the same water. So therefore the water will not, it's always the same water that will be treated. Chemical agents, chemical agents means, perhaps you have to wash the chemical agent, the rest of them, afterwards. So you need more efforts concerning the water treatment, and you have chemical agents. And if you have really dirty, really cohesive impurities inside your material, wow, you would need even more chemical agents and more efforts and more temperature. So this is the worst case. This is the maximal effort that you will do.